Good afternoon, everyone. In this video tutorial, I'll be showing you how to graph a piecewise function. In this case, we'll be solving question 6. Draw the graph of the following functions, f of x and g of x. So we start with the f of x. As it says, in this case, this is your instructions. This is your domain, your input value of x for this value of y to be defined, rather for the function of to define y. So we're going to follow these instructions in order to graph the function. So now in this form we are just sketching, we're not drawing to scale, so you have to pardon my sketching anyway. So in this case, this is the graph of f of x. This is x and this is y. So whenever you see a constant value of y here, just know that here you have a vertical line. Yeah, it depends with the instruction you have, whether the line will be infinity, from negative infinity to positive infinity, or to be in a given range. In this case, x values, the domain, the input values are from 0 to positive infinity. So how do we graph such a function? We already know that the value of y is 4. And we already know that this line is constant. It's just moving in a straight vertical line. So just come here and say, okay, this is where my y is equal to 4. And I'm told that where y is equal to 4, the line should begin at least where x is 0. So x is 0 in the y-axis. We all know that. So whichever value I'm going to pick from 0 to positive infinity is to still give me the value of y as 4. So in this case, I don't have to stress. You just have to draw a line from here to there, and you label this as y is equal to 4, or gf of x is equal to 4. You are done with this one. Let's go for the next one. This one says whenever x is less than, where in this case 0 isn't included, yeah, to negative infinity. So we all know that this is more like the opposite, So we just draw a line which goes this way, because this is the negative values, to declare the negative values. So this one goes this way. You are done. This is where y is equal to negative 4. This is how you graph the first one, and you are done. There's nothing much to do here. You are done. This is how you do it. Let's go to the next one. The next one is a bit complicated, but for this one, this is a modulus function. It was derived from a modulus function. Let me just give you an example. Yeah, if this function seemed to be, it was like y is equal to plus or minus 4. This is a modulus function. Or let me say y is equal to 4. So you know that y will have two values of the negative and the positive side. Let's go to the next one, which is g of x. G of x. Let me draw a rough sketching here. This is my x-axis, this is my y-axis. So as I said earlier, whenever you see a single value of y here, it means it's just a straight constant vertical line. Whatever value of x which is greater than or equal to 2, it will still give me the value of y. As I said, don't forget, this represents the value of x. To your right, to your left, the values of y. So now let's graph. So where will our graph start from? Will it start here in the x-axis or where? Wow, no. It says x should at least be 2 and greater to the positive infinity. So in this case, this will be our 1, this will be our 2, this will be our 4. So here x is 2 and y is 4. It keeps going this way to positive infinity. So this goes to infinity. This is where y is equal to 4 such that x is greater than or equal to 2. Wow. Let's go to the next. The next says, in this range, if x is negative 1 less than x such that x is less than 2, then the value of y is negative x. Okay, now in this case, for you to be a little bit quick, just pick this first value and this last value. Yeah, so we can easily say, let me solve it to here. The value of y is equal to negative x. So where there is a negative x, we'll replace this negative 1 here. Y is equal to negative 1. This negative is from the formula. This one is from the given domain. Positive 1. So we know that the first values will have, let me say, x and y values here. So if x is negative 1, then y is positive 1. Okay, and let's go to the next one. We can just go to 2. Yeah. So if y is equal to negative x, then replace with this 2, which will be negative 2. Don't have to solve anything here. So we know that if x is negative 2, positive 2, then y will be negative 2. So let me say here is our negative 1, here is our positive 1. Then here is our value here. Then if 2, which is here, is equal to negative 2. So let me say negative 1, negative 2. This one will be somewhere here. So we all know that this line will move in this. Now let's not forget that our negative 1 is not included. So here you write this circle, a small circle, a little circle, and here a little circle. Then you join the two together. Okay. Yeah, so we are done with this one. And remember, imagine that this is your exam. You have to be a little bit quick. So you go to the last one. The value of y is equal to x plus 2. And the domain given here is just negative infinity to negative 1. So starting from negative 1 to negative infinity. So let's place with the negative 1 where there is x. Negative 4 x plus 2 negative 1 plus 2. Yeah, rather I don't have to include this other negative. So let's just say the negative here in here. So it's negative 1 plus 2. In this case, your answer will be equal to positive 1. So where x is equal to negative 1, you have positive 1. So draw a table of values here. X, y. So it's advisable to be smart wherever you'll be solving from. Yeah, don't do such kind of stuff. I'm just showing you within the same range because I don't have equipments to show you like so from another page you come to this and I hope you understand. So where x value is equal to negative 1, y is positive 1. So now we are from negative 1 to negative infinity. So replace negative 2 here Negative 2 plus 2 is equal to 0. Y will be 0. Negative 2, y will be 0. Let's put 3 here. Negative 3 plus 1. Then that means y is equal to negative 1. Yeah. So as you know, the laws of algebraic expressions, negative 3 plus 2 means you subtract but maintain the value over the bigger number, which is negative 1. Okay. Yeah. So if here is 3, you have negative 1. Anyway, these numbers are enough, so we can still try to graph. As you can see, this function starts exactly where this one was starting. Here it says negative 1, here it says negative 1. But the difference is this one is not included, this one is included. So now how do you show this? The first one you graphed was not included, and the second one is included. Well, let's see. Negative 1 to positive 1. So you will have to put a small dot inside, then you pull it out in a straight line. So let's go to the next. This is negative 1 comma 1. So let's go to negative 2 comma 0. You all know that y is 0 in the x-axis. So assume here is 2. So 2 comma 0 is here. Negative 3 comma 1, 1 is here. 3 is this side. So negative 3 comma 1 to be somewhere here. And now this moves to negative infinite. So I'll say positive infinite. This is how your graph will look like. Now this is your g of x. You can still name this one as y is equal to negative 2 comma negative 1 less than x, x less than positive 2. This one can be y is equal to x plus 2 such that x is less than or equal to negative 1. You are done. This is how to solve piecewise functions. Please subscribe to my channel, like and share. And I would like to see your suggestions in the comment below of what you think, how can I improve the video production and the like. I will appreciate. Thank you. Have a good day.